Now we're going to talk about the derivative of log base a of x. So in the previous example, we talked about the derivative of ln of x, which is log base e of x. But now we're going to talk about the derivative of any logarithm in general. So there's two ways to do this. One is by directly applying the chain rule. So what you're going to get is the derivative of log base a of u. The derivative of log base a of u with respect to x is going to be the derivative, or 1 divided by u, this whole term goes right here, times ln of the base, ln of a, times the derivative of this inside function. So u would be something like x squared plus 1 or something like that. That's using the chain rule. So without using the chain rule, it's like the shortcut, the shorthand, log base a of x d dx is equal to x, this inside piece, times ln of the base, ln of a, and then if this was anything more complicated than x, you would need to take the derivative of this. So this next example we're going to do a long way, and then I'm going to show you a shortcut method. However, this is really going to show you exactly how the chain rule will be applied when you have to repeat it. So for example 4, we want to determine dy dx if y is equal to log base a of a to the power of sine of x. All right, so here we go. We're going to get y is equal to log base a of a sine of x. So dy dx then is going to be equal to 1 over, and remember, it's the piece on the inside, so this piece, a sine of x, technically it's this whole thing. All right, we'll put an extra set of parentheses so we're not to confuse that, times ln of the base. So times ln of the base. Now what we need to do is multiply the whole thing by the derivative of the inside piece. Okay, so that's applying the chain rule. So here we go, we get dy dx is equal to 1 divided by a to the power of sine of x times ln of a. Now the derivative of this, this is a constant to a power of something with an x in it, so we got to use the thing from the last example. So it will be a sine of x times the ln of this. But because we had an extra piece, we have to use the chain rule yet again. Times, we got to take the derivative of this, sine of x prime. Okay, so let's just keep working it out. We get dy dx is equal to 1 divided by a sine of x times ln of a times a sine of x times ln of a times cosine of x. Okay, now let's notice what we can reduce. This is all over 1. Everything is being multiplied, so this is going to reduce with that, and this is going to reduce with that. So dy dx is going to be equal to cosine of x. Okay, now I'm going to show you a different way to solve that same problem. All right, now I'm going to show you an alternate method. This will not always work, but if you keep your eye out for a certain pattern, then you can use this method. So we have y is equal to log base a of a to the sine of x. Now, if you remember from log properties, you can take this piece and move it to the front. So you get y is equal to sine of x times log base a of a. Now this is very exciting because log base a of a is just 1. So then we get y is equal to sine of x. So what you want to keep your eye out for is this right here, if these are the same. If so, you're in some good luck because your life then becomes very easy. So the derivative, dy dx, is cosine of x. And you'll notice that's what we got before. Okay, so this one I want you to try on your own. Determine dy dx if y is equal to log base 2 of x squared. So go ahead right now, take a minute or two and try that on your own. Alright, good job. So let's see if you got it right. So y is equal to log base 2 of x squared. So dy dx is equal to 1 divided by the inside piece. So this piece right here, 1 divided by x squared times ln of the base. But then we need to multiply it by the derivative of the inside piece. So we have to take the derivative of this. Well, that becomes a relatively easy problem. We're going to get 1 divided by x squared ln of 2 times 2x. So then dy dx is equal to 2 divided by x ln of 2. And that's it.